Hi. In this video, I will show you how I made a circuit on CircuitVerse to convert from gray code to three 7-segment display. First of all, I'm going to explain the gray code, which is just a cyclic code that changes only one digit. And also this phenomenon applies to the and beginning. That code can be different amount of digits, but for simplicity, I am going to do only 4 digits. This code most of the times is used on encoders, which helps to know the place of the motor. Also helps to know the speed of the motor and which side is spinning. And second of all, I am going to explain the 7-segment display which, as the name says, it has 7 segments, which can light up in many different ways to display different things like numbers and letters. In this video, we are going to display only numbers which are going to be the angle. After we got that out the way, we are going to make the truth table, but before that, we are going to set the angle for every coded word, which just differs for an angle of 22.5. But for simplicity, we are going to round those numbers as shown on the screen. As we can see from the angle, it goes up to 338. We need 3 7-segment displays to display a 3-digit number. Now we need to create the truth table. For this one, I am going to show only for the first example where the number displayed is 0. To display the number 0, we need to light up the segments A, B, C, D, E, F, and segment G needs to be off. Now we make the same for all of the angles on 3 7-segment displays, and we get this BIS truth table shown on the screen. After the truth table, we create the K diagrams, which is short for Carnot map. A Carnot map is a diagram that can be used to simplify a Boolean algebra expression. And it goes like shown on the screen. You put the numbers one by one in order, like in the screen. And after that, we simplify it by doing groups of 2s, 4s, 6s, and so on. For example, we have gotten the first column, and we are going to find the logic function for the input A1 by creating the K diagram as shown on the screen. The first group is going to be made by where A and D collide, so we add that to the function as A and D. The second group is going to be made by where A and C collide, so we also add that to the function. And last group is going to be where A and not B collide, and we also add that to the function, and we get the end logic function. After doing that for every column, we get the function for every input for the first, second, and third 7-segment display as shown on the screen. As the last part is creating the circuit in CircuitVerse. First, we put 4 input and extend the lines, so it will be easier later. After that, we put 3 7-segment displays as output. We put a NOT gate for every output, and also extend the lines. After that, we start using the logic function. First, we put down the A and D gate and chows as input A and D. Second, we put down another A and D gate and chows as input A and C. And third, we put down another A and D gate and chows as input A and not B. Also, we label everything so it doesn't mix up. And last, we connect those outputs of AND gates to the input of OR gate switch, from we get one output. And that output we connect it to the input of the first 7-segment display on the input A. After we have done that for every logic function, we get this big circuit for which I'm going to test for every input, from the input 0000 to 10000, as shown on the screen. And we can see that we get the right output for every input, and that's about it. Thank you for watching, and bye.